Hello, this is Susan Poss at Spartanburg Community College. This is a question that one of my students sent to me from Chapter 7, and I'm guessing this is probably Section 7.2, maybe. Again, I'm not 100% sure about that. Sorry. Okay, now I got it. All right, so I've written down the steps here. The first step is to factor all the denominators. Well, the second denominator is prime, so I cannot factor it. But I'm noticing this first denominator can be factored. So on the next line, that's what you're going to see me doing. I'm doing absolutely nothing in the numerator except copying it down. In the denominator, I'm writing it in its factored form. And as I said earlier, the second denominator is prime. I think I'll go ahead and put that in parentheses because I cannot factor it. All right, so that's the first step, factor denominators. Second step is to determine the LCD. And this is a really long phrase, but we list each factor, the greatest number of times it occurs in any one denominator. Hold on, let me get it spelled right. List each factor the greatest number of times it occurs in any one denominator. And I think I left out an important word here, each unique factor. All right, so as you look at these denominators, you only see a factor of x plus 1. It occurs twice in the first denominator. It occurs once in the second denominator. And this little rule over here in red says we need to list it the greatest number of times it occurs in any one denominator. So the LCD for this problem is x plus 1 times x plus 1 because it occurs twice in the first fraction. All right, so that's step 2. Step 3 is you do this little comparison step. You look at what you want here in the LCD, which is 2 factors of x plus 1. You see that you've already accounted for these 2 factors here, but you're missing a factor of x plus 1 in the second denominator. So when you fill that in the denominator so that the 2 denominators now match, there's something called the fundamental principle of arithmetic, I think is what it's called, which requires that you fill in the same multiplier, numerator, and denominator. So really what you've done there is you've multiplied by 1. You haven't changed the quantity, you've just changed the way it's going to look. All right, so that was step 3. Step 4 is now that these denominators match, you're going to want to draw one fraction bar. Write that denominator down one time because it's now the common denominator. And then you want to write down these numerators. All right, so I've finished step 4. Now I want to work out the numerator, and I'm seeing here I've got some multiplication to do and distributing that -5. And notice where the negative came from. Don't lose that sign back there. Sometimes it's easy to overlook that. So I'm just working on the numerator right now. Let me just keep the denominator as it is and work out 9x plus 4. Distribute the -5 and get -5x minus 5. So I'm still working out the numerator. I'm seeing some like terms here that need to be combined, so that 9x minus 5x is going to give me a 4x. And then this 4, which is like the -5, is going to give me a -1. And then I'm just continuing to copy down this common denominator. All right, so I just finished step 5. The last step is to reduce if possible. And in order to do that, you would look in the numerator and see if you could factor it. and get one of those factors to cancel with something in the denominator. That's not going to happen because that numerator is prime. 4x minus 1 is prime. So this is where you want to stop. This is the subtraction completed. So I hope that helps, Tanner.